Hello, I'm Glivie. Now I will explain about combinations in discrete mathematics. In discrete mathematics, a combination is a way of selecting items from a larger set where the order of selection does not matter. This is the primary distinction between a combination and a permutation, where order is crucial. The core concept. Imagine you have 3 fruits: an apple, a banana, and a cherry. If you are asked to choose 2 of them to make a snack. In a permutation, apple, banana, and banana, apple are different because the order changed. In a combination, apple, banana is the same as banana, apple because you end up with the same 2 fruits regardless of which you picked first. The formula: the number of ways to choose $R$ elements from a set of $n distinct elements is denoted as Cn, R_nc_r, or more commonly with the binomial coefficient notation, binom n_r. Breaking down the variables: n, the total number of items in the set; r, the number of items being chosen. The factorial symbol, e.g., 4 equals 4 times 3 times 2 times 1 equals 24. Why do we divide by r? The term n_r is the formula for a permutation. Since combinations don't care about order, we divide by r. 2 cancel out all the different ways those r items could have been arranged. Example calculation. Question: how many ways can you choose a committee of 3 students from a class of 10? Solution: here, n equals 10 and r equals 3. Because being the first person chosen for a committee is the same as being the third, we use combinations. Binom 10, 3 equals frac 10. 3, 10 to 3 equals frac 10. 3 times 7. Expanding the factorials: frac 10 times 9 times 8 times 7. 3 times 2 times 1 times 7. The 7 terms cancel out. Frac 10 times 9 times 8, 6 equals frac 720, 6 equals 120. There are 120 possible committees. Key properties: symmetry, binom n_r equals binom n_r. Choosing 3 people to stay is the same as choosing 7 people to leave. Boundary cases: binom n0 equals 1, there is only one way to choose nothing. Binom n equals 1, there is only one way to choose everything. Pascal's identity: binom n_r equals binom n1 r1 plus binom n1 r. This is the logic behind Pascal's triangle. To deepen the understanding of combinations, it is helpful to look at how they relate to the binomial theorem and how to handle scenarios where items can be repeated. Combinations and Pascal's triangle. There is a geometric relationship between combinations and Pascal's triangle. Each number in the triangle represents a combination binom n_r, where n is the row number and $R$ is the position in that row, starting at 0. The row sum of the nth row is 2n, representing the total number of subsets possible for a set of size n. This visual tool allows you to find combination values quickly without using the factorial formula for small numbers. Combinations with repetition, stars and bars. The standard formula $binom n_r assumes you are picking from a set and cannot pick the same item twice. However, in some discrete math problems, you are allowed to choose the same type of item multiple times, e.g., picking 5 soda cans from a shop that stocks 3 different brands. The binomial theorem. Combinations are also called binomial coefficients because they provide the coefficients for the expansion of x plus y n. Problem-solving logic. The complement. One of the most useful tricks in discrete mathematics is using the complement principle with combinations. In conclusion, combinations are a fundamental pillar of discrete mathematics because they allow us to quantify selection without the distraction of order. Whether you are calculating the likelihood of a specific hand in a card game, determining the coefficients in a complex algebraic expansion, or structuring the logic for a computer algorithm, the ability to group elements efficiently is essential. Summary checklist. Order doesn't matter. If AB is the same as BA, it's a combination. The R factor, we divide the permutation formula by R. To remove the duplicate arrangements of the same group. Symmetry is key. Remember that binom n_r is always equal to binom n_r. Choosing who to include is mathematically identical to choosing who to exclude. Mastering these selection principles provides the groundwork for more advanced topics in probability, statistics, and optimization. Since combinations focus on the what rather than the how, they offer a clean, elegant way to navigate the possibilities within any finite